Fronius and Victron Energy easy system setup. Good day, everybody. Hello, welcome to today's joint webinar. Today we have got a very special webinar. We have got a Fronius and Victron joint webinar. I want to kindly welcome you once again to this. I want to introduce you at first step the team for today. That means from Fronius side, I want to welcome you. My name is Sandro Köhl. I'm from Team Trainings and Education. And my colleague, David Heineck, will support me throughout the webinar today. So he is in the chat and he will answer all the questions. So if you have any questions regarding Fronius in general or Fronius and Victron, just ask them to David. He will give you immediate response to your questions. From Victron side, I'm very happy to welcome Guy Stewart today. Hello, Guy. Are you here already?
Hello, everybody. I'm here. Thank you for the introduction. My name's Guy Stewart. I'm the Victron Online Training Manager.
Yes, thanks, Guy, for joining. So we will do together today the presentation. So I will do the first part and Guy will do the second part. So after the webinar, you will have the possibility to answer our questions live. So we will get all your questions during the webinar, and after our presentations, we will make a live question answering with David and us, of course. What's on the agenda for today? So my part is the Fronius part. I will introduce you briefly to our Fronius microgrid solution. I will also show you some system possibilities and advantages of the Fronius and Victron systems, of course. The main focus today, like you already saw in the title, is of course the easy system setup. So we will kind of do together a virtual configuration of such a typical Fronius and Victron system. Me, of course, from Fronius side and Guy Stewart from the Victron side. Okay, and the second part, Guy, maybe brief overview what you will present us.
Sure. So I'll be running through the Victron side of the setup and commissioning. So I've focused on the easy setup of Victron and Fronius in a system together. I'll discuss the design options, so where the Fronius fits in a Victron system in off-grid or grid connected. I'll also talk through some of the required steps that are required for commissioning and setup of the system, and some of the limitations of the design, some things you need to know before you'd step into one of these systems.
Okay, so thanks for that. I think very interesting and valuable content today. And let's start directly. But before that, I have prepared a quick poll for you. I will now present it to you. I want to ask you following question. You see now, do you already have any AC coupling experience with Fronius? So there are 4 possibilities. I already have AC coupling experience with Fronius only. Second possibility with Fronius and Victron. Third possibility is, no, I do not have experience so far, but customers or requirements are incoming and increasing. And the fourth possibility, no, I just want to inform myself and get an overview, use the time for education. I see many of you already voting. Thanks for that. I will just wait a few seconds until I will close the poll and of course present you the results. Okay, I see that most of you already voted. Thanks for your participation. I will close now and present you the result. And what is the outcome? The greatest part of you, I would say approximately 1/3, has got no experience so far, but of course customers are increasing their demands. 30% have already experience with Fronius and Victron, and the other 2, I would say roughly 20%, they have experience with Fronius, or they are just here to get an overview and just here for information. So thanks for that. I think the webinar will include valuable information for all of you. And let's just start directly into the webinar. So what is the Fronius microgrid solution about? So when we talk about off-grid and backup solutions, we are very, very proud, of course, to have such a reliable and good partner on our side with Victron Energy. So Fronius and Victron Energy are working together for a very, very long time. Many systems installed on a global level underline the great compatibility, and they have definitely the right products for your off-grid purposes. From Fronius side, which inverters are compatible with the Victron devices? So on our hand, we differentiate between our one-phase inverters and our three-phase inverters. So on the one-phase, for the one-phase markets, of course, we are fully compatible with the Fronius Primer from 3 to 8.2 kilowatts AC output power. And the M behind always stands for the number of MPP trackers. The M in our case is always for 2 MPP trackers. On the three-phase side, we are fully compatible with our small one, the small SIMO, again from 3 to 8.2 kilowatts dual tracker inverter. And also for bigger application, that means if the system size gets bigger, we also have the correct products for perfect match Fronius and Victron. We have got the SIMO up to 20 kilowatts and the Echo, our cost optimized project inverter, to a max of 27 kilowatts with a single tracker cost optimized project inverter. So these are the inverters which are fully compatible and also fully tested out in the fields with Victron components, on which Guy will give you afterwards, of course, detailed information. Good. Maybe also when it comes to off-grid and backup solutions, sometimes asked about genset solutions. That's of course not the main topic today, but I also want to give you the information. Fronius has got, of course, also the solution for effective genset controlling. That means you see here on the device, we have got the Fronius PV system controller, which can, for example, be included in such a system, in a genset-based system, where you integrate your PV system, your Fronius, with Fronius inverters, and therefore the PV system controller does all its regulation regarding the genset and the PV to supply your loads and of course save maximum fuel costs. I just want to tell you that, but of course today we have got the focus on Fronius and Victron and the easy system setup. And now, of course, the first question raises, how can Fronius and Victron systems look like? Principally, we differentiate between AC and DC coupling, and of course, Fronius related, it's the most important thing we are focusing on is the AC coupling part, because that's actually the situation where the Fronius inverter joins the system and comes into the game more or less. What can you see here on the scheme? You see our Fronius inverter here and the PV generator, which is directly connected to the household. That means to the loads in general. And on AC side, we have got an inverter charger from Victron. That means the inverter charger runs as controller and builds up the electricity grid. On the AC path, you also see the possibility with Victron to add a genset. That means you, in case there is not enough sunlight, you do not have enough energy, and the battery, which is therefore connected, is low, you would have the possibility to connect a genset and of course recharge the batteries and also supply the overall system by the genset. And also grid connection is possible. In some cases you have got, you have grid, but you have maybe sometimes weak or bad grid. that would also be possible as a central core element, the inverter charge of Victron, to add such grid. If it's available, you can add it. What's the main advantage of this system? Of course, you have got the highest efficiency when production and consumption are at the same time. That means in typical daytime situation, this system has got big advantages. Why? Of course, you directly supply the loads from Fronius, from our inverter, to the household. You do not have any steps in between, and therefore have got the highest efficiencies. A next step would be AC and DC coupled. So that's kind of a combination of both advantages, also from DC coupling. You see here again the same scheme like we had before with the AC coupling and the inverter charger of Victron and our inverter. And now there comes into game or into the scheme the MPPT charge controller of Victron. That means the PV generator is kind of split up. So one part is given to the Fronius inverter and the other part is given to the MPPT charge controller of Victron and is directly connected to the battery. What is therefore the big advantage? Of course, you have therefore again the high efficiency at daytimes when PV power is generated, because you can directly supply your loads, of course, and you can directly recharge your battery. You do not necessarily need therefore the genset. Of course, you have the direct connection to the battery. The inverter charger, of course, controls again all these three components: battery, the grid, and the generator, and also again is the grid, builds up the grid, and therefore you have got it again as a core element. We can, of course, have perfect communication, and maybe you also ask how this communication is done between Fronius and Victron, and therefore we come to this, let's say, phenomena more or less. So that's the frequency watt curve. That means we are communicating with all the Victron devices with the inverter charger via frequency controlling. Therefore, the Victron device is simply increasing the frequency in case at the specific SOC value of the battery. You can see here. So, for example, at 90% SOC value of the battery, the AC frequency is increased by the inverter charger of Victron. And what happens on the other side, you see here on the second graphs, if the AC frequency is increased, the PV inverter automatically reduces the feed-in power, and therefore you have an automatic power reduction when the battery is fully loaded. I show you now on the next, you see here on the animation how this works properly. So SOC value is reached, frequency is increased, and on the other hand, you see the output power is reduced at this, and up to a specific frequency, the inverter is more or less completely controlled and does not produce if it's necessary. And that's the perfect communication between Fronius and Victron. So why is Fronius and Victron first choice? Why should you rely on such a system? Of course, we have, the full configurability and successful installations worldwide. We are fully compatible with all our inverters. We have together a kind of strategic partnership, so we are working strongly together. We are strengthening all the cooperation. Like today, we are doing webinars. You see here a picture. We are currently doing trainings. That was in January this year, where we also can see me and David. We have had training at the Victron facility. So we are really focusing the partnership and have a perfect match, of course. And what is also a big advantage, we have a technical support commitment. So we provide you full support if you call the Fronius hotline regarding the Victron components too, and in combination with Fronius. And also on Guy Stewart's Victron community, you find a lot of information and support and regarding all open questions to Fronius and Victron. But of course, Guy will tell you in following presentation. So how can you now successfully set up a system, Fronius and Victron? So therefore, we have prepared for you 4 easy steps how you easily and successful configure your system. And these are the following 4 steps. First of all, you have to do, of course, the installation of the PV generator. That means all the cabling, all the module mounting, and all the commissioning of the devices. This is always the first step. On the second step, we recommend you to do the setup of the Victron configuration. That means, of course, you can also set up an ESS storage system with a battery. That would be, in best case, the second step. And on the first step, you do the AC coupling. That means you prepare everything for us, for Fronius. It means you complete all the wizards within the Victron device and with the VBus configuration. And then last part, there comes the Fronius. That means you actually supply our Fronius inverter by AC of Victron. Then you have to do some settings. I will now show you, of course, and to do the commissioning of our data manager. So that will be the focus. I will now present you what to do when setting up the system and make it a success and make it work properly. First of all, there are some basic design rules. That means in order to guarantee the success, you of course have to be sure to keep that in mind, these 3 design rules. On the first hand, we have got the correct dimensioning. That means the 1-to-1 dimensioning. That means the peak power of our PV inverter must not exceed the maximum power of the inverter charger. It means all the inverter charger have got a maximum power in kilowatts amps, and you should consider this 1-to-1 rule to our Fronius inverter and our power classes. Nevertheless, we of course from Fronius recommend you to do an overdimensioning. That means on the DC side, you can of course overdimension our inverter. We also recommend it. It's possible up to 150%, slightly different from our inverter types. Just check the data sheet, but in general you can say 150%. Why? Because with an DC overdimensioning, you should be utilized for more maximum independence and to make the system even more efficient. Then we have got a special microgrid setup. That means that is also a key essential for the system design. So for all this snap inverter, you see the display on the front side of the inverter. We have got this microgrid setup in 50 and 60 Hertz. So that's a setup which is pre-installed at the Fronius inverter, which you of course have to choose, and which is tolerant concerning voltage and frequency limits, and therefore necessary to realize this frequency controlled power reduction and frequency controlling via Victron. And of course, we provide you planning support. So we have got a real good network on a global scale of technical sales advisors. We will, and also Fronius system partners who will help you with the right inverter selection and also the string configuration. So Fronius is on your side throughout your project, of course. I will now show you one very good example, a best practice I found recently on the Victron blog. It's a very impressive solar powered system. Actually, it's agriculture in Mali in West Africa. So it consists in total of 7 systems, in total system size of 520 kilowatts. And like I told, it's subdivided by 7 installations, and the biggest standalone installation is with 6 Fronius Echoes and 5 Victron Quattros. Therefore, also batteries are connected, these types of batteries, and also a genset can be integrated, like we saw in the scheme, even in case of backups if you need it. But the characteristics are with this system, which works really properly, initial commissioning 2014. Of course, they are steady improving it. You have on a long time experience already, you meet 98% by solar and only 2% are met by genset. Of course, the genset is important for this 2% that you have overall energy supply throughout the year. But that's a very successful, very impressive system in Mali. And what is, if you want to set up such a system, what is now to consider Fronius-sided? So we have seen already the basic rules for accurate system design, like the 1-to-1 rule. It means the peak power of the inverter must not exceed the maximum power of the inverter charger of Victron. We have the setup microgrid 50 and microgrid 60, the data communication, of course, and within our inverter, we have the data manager card. That means you also have to do an initial commissioning of at least one data manager. If you have, for example, multiple inverters, this is necessary. I will show you now step by step what to exactly do. So, like we saw the system in Mali, there are 6 Fronius Echo, and now maybe you ask, how are they interconnected together? So that's very easily possible with Fronius, with our so-called Fronius solar net ring. That means this solar net ring you can see here is a specific protocol for communication between our Fronius inverters. That means on every snap inverter you have got an input and an output, where you just combine it with a Cat5 network cable, the inverter, possible up to 100 inverters, of course, you can connect within one ring. We, of course, recommend 20 to 30 inverters to a max, which can be monitored, and all the data communication can be done by one data manager. That means you only have to equip one inverter with the data manager and can save costs for the other ones. Yes, that's important. What is important when setting up such a ring is termination plugs. That means at the end of the ring, you have to be sure to have such termination plugs. I put a picture in here to plug it in. And of course, to address the inverter, that means, for example, for inverters, you have to set number 1, 2, 3, and 4 of the inverters. And in case you have got multiple data managers, that would also be a possibility. You be sure to have the master-slave position to make one data manager as a master. But in normal case, you just have one data manager for the whole ring. That's important for connecting multiple Fronius inverters. You see here again an inverter from us from another perspective. Where are these connections? You see here, this is the solar net in and the solar net out. It's also clearly defined on the inverter. This is the data manager card, which must not necessarily be integrated in every inverter, so you can order it, or you can also order light versions without data manager, for example, to save money if you have such a ring and you only need one, of course. And that are the key essentials when doing this ring and when realizing such a solar net ring. That would be the first step from Fronius, to connect these inverters, and the next step would be to do a selection of this microgrid setup. So I already told you that's a special country setup for such off-grid applications. It's available for 50 Hertz and for 60 Hertz, depending on your grid type and on your frequency. This is necessary to make this control possible via the Victron device. We have therefore these extended voltage and frequency limits, which allow this power reduction, this frequency watt curve we saw in the previous slides. And it's very, very easy to select. It's just 2 steps. You just have to press 5 times on the third button from the left to open this menu. Just enter the code 73887, admit, and then choose the MG50 or MG60, and then the inverter will automatically reboot, and you have done all the settings on the inverter. So you see easy 2 steps to realize this microgrid function. And then the next step would be to do the commissioning of the data manager. That means we have got this one data manager card, for example, for the whole ring. We have to do this commissioning and bring the system, of course, online. Therefore, you have to activate the Wi-Fi access points that can also be done on the inverter, very easy. Then the inverter opens his own network. You can connect with any mobile device, whether it's a smartphone or a laptop. That would be possible. Connect to the inverter and then just do 2 setup wizards. There is the technician wizard and the SolarWeb wizard, which can be very easily done within, I would say, 5 minutes. And the initial commissioning is completed, and it's about to run, and you have got the full system in the Fronius SolarWeb, and it's fully commissioned. Why is the Fronius Data Manager, the thing you have to commission, so important for the data communication? I've pointed out here once again. So here you see it again, this Data Manager card. So you can connect it to the SolarNet ring. I already told you. That's the key element. For example, if you have a Fronius smart meter, of course, in off-grid situations, you will not have this Fronius smart meter, but if you have a grid-tied application, this smart meter, this data manager card communicates via the smart meter at the feed-in point. From Victron side, important is we have got this sends out the protocols, the Modbus TCP and JSON protocols, which can be directly linked to, for example, the Victron color control GX or via a network. It means this is very, very important to transfer in parallel to third-party components, in this case, the Victron color control, the data, and that you have this, for example, on-site monitoring, and you receive lifetime data and all the log data from our inverters, and you have it in the Victron device. Yes, and also you bring the system online in our Fronius SolarWeb portal, so that is also highly appreciated by our customers. Just very quickly, a rough screenshot from the starting page of the SolarWeb portal. You see here all the current energy flows of our inverters. You see the energy balances. You can do remotely updates via the Fronius SolarWeb. So that's a very, very good tool and very appreciated by our customers, where we have got lots of possibilities if this system is online. If you have the data manager, of course, you have this advanced views like here, and therefore we strongly recommend it to bring it in Fronius SolarWeb. But from Victron side, you have this on-site device. I know that this is the color control out of the GX series. I know there will come a new device, the Cerbo. Guy will also maybe point out some things about that. But this one is also very appreciated for off-grid situations. Of course, why you have this on-site? That means you have this real-time monitoring all the time. It's very, very easy to understand. Just see here, for example, our Fronius inverter with the actual power. You see all these simultaneous energy flows, the SOC value of the battery. So this can be easily integrated close to your system, and you have all the time the overview. And you can, of course, do advanced views just here, for example, with the the Fronius Cymer, you can control the phases, the voltages, and the amps if the system is running properly. You see here. So that's also a key advantage of such on-site monitoring device from Victron Energy. Yes, and the last slide from my side. Now, Fronius support, you know, Fronius support is very, very important for us. So we want to provide the best support on a global scale. How do we achieve this best support? Okay, we have a good network of Fronius system partners. So these are installers, which are our strategic partners out in the fields. They are well educated, so they all had trainings by me and my colleagues. They are well educated professionals in terms of Fronius, and of course also in the regions where such off-grid systems are very popular. We also have joint trainings with Victron because that's very, very important for us. And yes, they have got the expert knowledge. We have got also technical sales advisors. So we have a lot of subsidiaries, approximately 30 subsidiaries on a global level. But in countries where we do not have a subsidiary, we are also very good connected with technical sales advisors. That means there's one person out who does all the technical sales advice, gives you support, and yes, we are widely spread. And the tech support international. So we have a free tech support. That means you can support us anytime. We have really expert knowledge also on the phone, which give you individual help to your system, to your problems. So we are here for you anytime on a global level with our technical support hotline. Okay, that was it from my side so far. Now I will directly hand over the words to Guy. Guy, are you still here? Can you hear us?
Yes, I'm still here. Thank you very much. Just getting myself unmuted. Now, thank you very much for a great presentation. It's very informative, of course. I'm going to now change the presenter. Whoop, I think that's the wrong one.
Guy, we saw your screen briefly.
Briefly, let's try it again. Okay. So, hopefully this one works better now.
Yes,
okay.
Now
Can you see my screen
working.
now?
Yes, it's working.
Wonderful.
Thanks for that.
Works for me too. Okay, thank you very much. Thank you everyone for listening. I'll take a deep breath and a drink of water before I begin. So thank you first, Sandro, for that presentation. I believe you've covered most of what's required to know. I'm going to go now into a little bit more detail on the Victron side of things. Firstly, I'll just talk about the Victron and Fronius relationship, which you mentioned. You mentioned a few of the technical details, and I think I should also go into some of the more personal details about why Fronius and Victron are a good partnership to have. We have very, let's say, ideologically similar companies. We're both focused quality, and also the organizations of the companies are quite similar. We're both private companies, so we're not beholden to large boards or anything like that, or publicly traded, which allows us to think on a different time frame and allows us to make partnerships and relationships so we think going to serve each other in the long run. Also, fundamentally, Fronius and Victron are quite different in their approach and quite different in their background technically. Fronius coming from welding and other AC supply, and Victron coming from battery inverters. So we've focused at low voltage, whereas Fronius is focused at higher voltages. And we have a very, very, let's say, supportive and sympathy. So we're both very happy with the relationship. And over several years now, we've been able to refine the partnership, and the performance of our systems respectively, and are very, very happy with how things are working out of the box basically now together. Very, very reliable systems. So definitely a preferred partner. I'll briefly run through some of the basic system topologies, some of the designs. So this is a basic system. This is a load connected to a grid. So this is a household. This is not an independent system where we're off-grid, and I will talk about those as well. Often what will happen is the AC PV will come in first, at least in the Australian market. So this is the most cost-effective way to begin a system. You want to save money on the daytime power consumption. So you'll add a Fronius AC PV inverter and panels. But the issue with a system like this is if the grid goes down, then the system goes down as well, and you lose power even though you have power production on the roof. One way to get around this, to help support this system and to add more nighttime autonomy. So the other issue with a system like this is that during the day, your loads are provided for by the AC PV, but at nighttime without any storage, then you are buying again from the grid. If you include a Victron inverter charger with a battery and a grid meter, you begin to use that existing bus of the grid and the loads in the AC PV inverter, and you can now efficiently use that system to charge a battery. So during the day when there's surplus power from the panels, that can be used to charge a battery. And then at night when there's a deficiency in the solar, but extra load, the battery can discharge through the Victron inverter charger, and that can then provide for the loads at nighttime, meaning the grid power is reduced. One of the ways we do this is with an energy meter in a system like this. So you can see that in the diagram, connected to our GX device. And this energy meter will look to see if there's any import or export of power. So if the system is importing power, the battery will discharge through our multi-plus. And if there's export of power, then it will charge the battery. You can also then add the additional essential load circuit into a house. So keeping all the existing circuits in place, you can add a new circuit to the house, and this will allow you to run loads when the grid drops out. So even if the grid is disconnected, that will remain intact. Now, another option as well, and we can keep building these systems up. It's all completely configurable with which elements you include. You can also add DC PV. So this is using a Victron MPPT, and this is directly connected to the battery via the DC bus. And this is in addition to the AC PV in this system connected to the AC input. Now, the advantage of doing a DC PV in a system like this would mean that if the grid drops out, the AC PV in the Fronius will also be disconnected. In a system like this, you'll still have some charging even when the grid is disconnected. It's also possible to use a DC, but we're not going to be talking about that much today. Now, with some limitations, it's possible to put the Fronius on the AC output of the Victron. So in this case, when the grid's normally connected, the grid will be providing the sine wave, which everything will connect to. So the Victron Multi-Plus will synchronize with that grid sine wave, and so will the Fronius. The Fronius AC PV will be synchronized to the same sine wave. But in this system, if the grid drops out and that AC sine wave is disconnected, then what happens is that the Victron Multi-Plus will create the sine wave instead. It'll take over, it'll form that grid wave, that sine wave, on the essential load circuit, and the Fronius will synchronize to that instead. So you can still charge your system during a power outage when the system's like this. Now, there are limitations on a system like this, which we'll talk about in a little bit more detail. It's also possible to have all combinations of the above in a grid-connected system. You can have AC PV connected on the input, and this is unlimited or limited to your circuits and your grid supplier. You can have AC PV on the output, and this is limited to the size of the multi-plus in the event of an outage. And you can have DC PV connected directly to the DC bus before the multi-plus. And this is also relatively unlimited, relative to the size of the battery. You can't have too big a PV array on the battery if the battery is very small. Skip through that one. Now, we've got a new series of inverter charger. It's still limited in the range, but the multi-plus 2 is now widely available in a 3K and 5 kVA versions. And it comes built in with its own current sensor, so you no longer need an external energy meter in this arrangement. Now, one of the issues I mentioned was if you only have AC PV. Sorry, let's wind up a little bit. One of the other potential issues, I should say, is in an off-grid system. Now, in off-grid, without a reliable AC supply to support the system, if you only have AC PV from Fronius, if the system becomes fully discharged, what happens is that the battery will then send a signal through voltage or some other way, if it's a lithium battery, to the inverter charger, and the inverter charger will shut down to protect the battery when it gets very, very low. In this case, the Fronius depends upon that sine wave that the inverter charger is creating to start up. So you could have an issue where the system gets too deeply discharged and becomes stuck. Now, what you need to do in that instance is provide another source of power. This could be a generator, which you could start up, or you could also add a Victron MPPT on the DC bus. Now, this Victron MPPT doesn't depend on the multi, so if the battery voltage is very low, and in fact it can start at 0 volts in the form of, let's say, the salt batteries and the zinc bromide batteries, they can get to very, very low voltages. The Victron MPPT will still start up then. Then, once the battery voltage is up, the multi-plus will wake up, and the system will then start up again, and then you'll get the support of the Fronius AC PV. This is a much, much more reliable system. And if you are going to do off-grid work with AC PV, it's really strongly recommended to have a DC MPPT in the system as well for that blackstart capacity. Now, if you have a generator as well, that's another way to do it. But to start a generator is a lot more inconvenient for an end-use customer than just to wait until the sun comes out to bring the system back online. Or if there's nobody on site at all, that's an even bigger issue to start a generator. Generator runs out of fuel if it's an auto start. Having that DC MPPT allows for that black start capacity. Now, if you don't have a DC MPPT, another option is to do it like this. So on the Victron Multi Plus, there's 2 AC outputs to the system. The first AC output can be considered the essential one, the reliable one. It's always connected when the Multi Plus is on and operating. But there's a second AC output, AC out 2. And that AC out 2 has an internal switching relay inside. So it can be connected or disconnected. And you can program that depending on certain parameters. Out of the box, it only works when the AC input is connected. So if you've got a generator running, you'd have a very large load, let's say a hot water supply or an air conditioning system or something like that, connected to the AC out 2. So that only runs when you've got the support of AC input. But in an off-grid system, you might wish to have it instead like this, where the loads are connected to AC out 2, and they get disconnected when the battery state of charge reaches, say, 15%, or the battery voltage reaches a low threshold point, but not shut down, and that only leaves the PV inverter connected on the AC1. When the PV inverter is the only thing connected on the AC1, then it'll still stay online, and then the next morning when the sun comes out, it'll generate power, which will charge the battery up, and that'll then close that relay and reconnect the loads on AC2. So, other reasons to potentially choose AC or DC PV. Now, I have both in my system, and I designed systems with both when I was selling power systems. I'm not biased to one or the other. It's important to know when it's important to use one and when one has bigger advantages over the other when designing systems to get the best outcomes for your customers. So, the number one reason is if the major consumption of energy takes place during the day. AC PV inverters from Fronius are extremely efficient at converting panel power to an AC sine wave to power AC loads, right? That's what they're optimal at, and they're much more efficient at doing it than the battery inverter is converting DC power to AC power from a battery bank. So that's one reason to go. However, they're less efficient when you want to charge a battery. And you can see why. You have to go through the transformity step of DC from the panels to AC to the Fronius to DC back again through the Multi Plus to charge the battery again. So there's an extra step of transformity that has to happen in that step. So if it's predominantly nighttime or predominantly battery charging, you're better off with a direct DC to DC charge. Now, one of the other pros of AC PV is less and thinner AC cabling. Well, that should be DC cabling. Less and thinner DC cabling. So you can run solar arrays from further distances away. You don't need as many wires. You can run higher voltage strings. So everything becomes a lot more efficient on the wiring side, including the speed of installation and other things. The cons, though, if in your off-grid situation, or when the AC PV is connected to the output of the multi instead of the input, the one rule may apply. So this limits the system size to the size of the inverter charger. You also need to do extra programming steps. The system will not recover from low battery if there's no backup. You have potential clock and timer issues. So the situation with how the systems communicate is through this frequency shift power control. So normally when the system's happy in Australia, it's running at 50 Hertz. And at 50 Hertz, the Fronius will give full throttle to the multi-plus in the system. It'll give as much PV power as it can. But as the batteries begin to fill up, or they want to reduce the amount of charge in an absorption phase or something like that, then what happens is that frequency will increase. As the frequency goes up, let's say to 51 Hertz, anything that uses that frequency as a timer, which can be old clocks and things like that, will also speed up. So if the clock in the house is using that 50 Hertz frequency to set itself, it can begin to go faster than you'd expect for normal time. It's not a huge issue, but it's something to be aware of. It's also not suitable in boats or vehicles. AC PV is potentially more dangerous than a DC PV with lower voltages. So, and also earthing issues. AC PV requires an earth fault alarm and things like that. And that's more difficult on a boat and vehicle to do safely. So better off with DC PV via a Victron MPPT on a moving vehicle. Now, DC PV. So use it when most of the energy needs to be stored in the battery. It can be more effective than AC PV in very small systems. So we make very, very small MPPTs down to 20 amps, I think it's the smallest one. Maybe there's even a smaller one, 15 amps. There's no Fronius that's that small. So in very, very small systems or systems where there's no AC at all, only DC systems, then a DC PV system makes a lot more sense through a Victron MPPT. They're also extremely efficient at charging batteries. Their conversion is very, very good, but less efficient when running an AC load. So better for charging batteries, more efficient if the energy needs to be stored. They're easy to set up, at least in a Victron system, so virtually plug and play. There's a little bit of programming required on the system, but no additional integration programming required. And they can start up a system from a blackstart. The cons are they're not very suitable for very large arrays. So we do sell quite a large DC MPPT, but it's still only limited to about 5 kilowatts, 100 amps at 48 volts. Now, Fronius do much, much larger AC PV inverters than 5 kilowatts. So if you're doing very, very large systems, then AC PV is definitely worth considering. DC wiring is also required. The lower voltage on the panels means you need more higher currents basically to get the same power, more and thicker wiring, shorter runs, and lower maximum PV panel voltages. So the other thing we mentioned, AC PV on the input or the output. So on the input, you don't need to follow that one-to-one sizing rule, but during a blackout, the inverter stops, the AC PV Fronius stops. On the output, the one-to-one rule does apply, but during a blackout, the inverter will keep going. In this arrangement, you need to have the frequency shift set up. So I'll just mention briefly Fronius versus other brands. So Victron does support other AC PV inverters, but Fronius is the one we support the most, the one we've got the best relationship with. And there are some additional features that are available, which I'll go into in a sec. So a bit of technical background. The operating principle is frequency shifting. So when the battery is full, the multi will increase the frequency. That'll reduce the power because the AC PV inverter has been programmed to detect that frequency shift. And then when the frequency shifts back down again, the PV inverter will also produce power and the multi will start charging the battery again. That's the relationship. The rule is that PV power is not allowed to be more than the multi power. That's when you're in an off-grid system. And the frequency shift is always needed because that's how we control the adjustment of the power. I'll show you how to do those in a sec. Now, one thing that's not required, but highly, highly recommended in an off-grid system is the connection of a GX device. So this is the Serbo GX, this is our newest GX device. We have about half a dozen different GX devices, and to find out which one's appropriate for your system, you can Google GX product range and you'll see the options there. This is the brain of a Victron system. So you can see here all the possibilities for connection here, and they're vast. Up the top right of the image, you can see the compatible AC PV inverter. In this case, the Fronius. It can connect into a local network Ethernet router or switch, and that then connects into the Ethernet port of the Servo GX, and that allows them to be on the same local network and allows them for them to connect. You can also connect a myriad of other accessories into this device, and what it does is it brings them all together into one interface for the end user to see, for the electrician or the installer to configure, or for the remote operator or troubleshooter to be able to see what's going on. There's a lot of features that come with this, and it's a highly recommended feature to have. But it is not essential. In an off-grid system, our multi-pluses can frequency shift power control an AC PV Fronius inverter without a Servo GX or without another GX device. They are required if you are going to have an ESS system. That's where the system is connected to the grid and the Victron system is adjusting the power in real time to make optimum use efficiently of that grid system. That's when they are required. But in off-grid, they're not. They're still highly recommended. So this is the display on the front of the GX device. In this case, only a Victron DC MPPT is connected. You can see it down the bottom right. On the left-hand side, you can see the battery connected, so the battery state of charge. Up the top left, the AC input, if anything's happening. So in this case, it's not. And up the top right, we've got the AC loads connected either to the output or through the unit. If we now connect a Fronius to the AC output and we detect it, and I'll show you how that's done in a minute, you'll get a special display on the GX display which says Fronius, gets a little badge, and you see the power production of the Fronius PV inverter separately. In this case, this one's been configured to be connected to the AC output, so you see it on the output. Here's another example, this time with two Fronius inverters connected. Well, in this demo, they're the same power output, but let's say there's two. One on the AC input, so you can see there it's connected via the blue line to the grid side, but the Victron system can still see it, so I can still use it for charging or for running loads. And one's connected to the output side, so it'll survive if there's a grid outage, whereas the one on the left-hand side will also be disconnected in this case. One of the other big advantages of a GX device is access to VRM, that's Victron Remote Monitoring Portal. You can see the website down the bottom there where you can test out a demo. VRM provides real-time system data. You can log into systems and see what's happening as if you're sitting in front of them. It also gives system overview data, all connected devices, detailed data logging, diagnosis, reports, and much, much more. Here's a sample of my system. So this is the dashboard overview. It's showing the last 7 days of production and consumption and the battery state of charge at a glance. If you want to find out more about VRM, we also have a VRM specific training. Here you can see in the device list of the VRM, my connected Fronius PV inverter. It tells me the serial number and a few other things in there if I get into the back of it. Here's a detailed or advanced view. So here you can see the production curve over 7 days from the Fronius system. You can see in the last 3 days, the weather's got cloudy and rainy here. So my battery is discharged. So you're seeing production drop on the Fronius, and you're seeing at the same time the state of charge of the battery drop accordingly. Today was a little bit better, but still only reached 80% state of charge. Here's a little snapshot of the GX product overview, but I'd encourage you to Google it and find out which one's right for your application. So I'll just talk a little bit about system sizing and design and selecting components. We mentioned the 1-to-1 rule. There's other system considerations that need to be made as well. One of those is that the battery size is the similar or related to the size of the PV array. You don't want to have a gigantic PV array attached to a tiny little battery. And there are system sizing rules around this, depending on if it's lithium or lead. Generally speaking, Victron MPPTs, the DC MPPTs, are a lot more responsive to battery voltage than an AC PV inverter is. So if you can imagine, the Victron MPPT sees the battery voltage directly through the system and can respond extremely quickly by shifting its power point. the Fronius system needs to receive a signal through the multi-plus and then shift its power point. So there's an extra step that has to happen. This is one of the reasons why there's that sizing limitation on the multi-plus and the AC PV inverter, in case there's a very full battery, for instance, and then so there's a large load that's running, and then the large load switches off, but the Fronius PV inverter has been powering that load. There'll be a moment where there's extra power in the system, and the multi-plus has to be able to absorb that, or the battery has to be able to absorb that, or else the system voltage will rise. So here's a few of the factors to determine inverter charger size. So the battery's rate, how much you can discharge from a battery safely, whether you want to feed any power back into the grid or not from the system. So we can also feed back, if that's allowed in your area, from DC. So if there's surplus inverter or charger capacity, then it can convert DC PV back into AC sine wave, and that can be fed into a grid. How big the AC PV is on the essential output load. If you know you want a big AC PV inverter, you have to have a big multi-plus to accommodate it. And then finally, the size of the loads, how big the loads you want to run are. So now I'm quickly going to run through some steps for commissioning on the Victron side. Firstly, update the firmware of all Victron products. So you should always update firmware on a first run. We fix bugs in firmware quite regularly and improve system performance. However, once the system is running and stable, you shouldn't update firmware. It shouldn't be required. So settings for multi-plus in VE configure. The main one you need to look at, the assistants, there are a set of configuration options that allow some more advanced features. There's two ways to go about it, either using the ESS assistant or via the AC PV inverter assistant. You can find out more about assistants at that link. So once you've opened up, you're connected to the system via an MK3, you open up VE configure, and then you add assistants. You can connect the ESS assistant. This is if you're grid connected. Within that assistant, which is kind of like a wizard, which you click through, you'll select whether you have a PV inverter connected. If you do, you click yes, and it'll ask you some questions based upon the sizing. So the frequency range you leave by default if you're using a Fronius system, and the total solar power system, make sure that you're following that 1-to-1 rule. So you need to enter how many PV panels you've got and how big the PV inverter is. If you're off-grid, so the ESS assistant's for grid connected, if you're off-grid, you use the PV inverter assistant, and what this does is it turns on the frequency shift if the batteries need to stop charging. And it's very similar as the previous one. Just fill out the wizard, keep the frequency the same as the default in a Fronius system, and set the total PV power in there. Now, Victron is working on products that do not require the assistant stage. So our new inverter RS Smart supports AC coupled PV out of the box without requiring any assistance. And I imagine this will be the way it goes in the future for other systems as well. But for now, that's required, just something to be aware of. I'll skip through this very quickly as it's already been covered by the Fronius part. So you've now, at this point of this installation, you've set up the frequency shift. You'd now set up the AC PV. So set your grid parameter, set your codes, confirm that it's been set up on the unit, and then do a system test. Now, setting the settings on the GX device. First one you need to do, if you've got a GX device, is to set the location of the PV inverter. So you head to the PV AC inverter menu on the GX device in the settings. Once you've navigated to it, you can detect the Fronius inverter, and I show you how to do this in another training that's available on our online training portal. And then you set the position to AC input 2, or the AC output of the inverter. There's also an option to turn it off. So if you have multiple systems on the one network, you might not want to use it, let's say, so you can switch it off. There's another option here, which is the Fronius zero feed-in. Now, if you're connected to the unit, suddenly the multiplus can't control the frequency anymore because the grid's setting the frequency. So in an off-grid system, it can adjust the frequency up and down, but in a grid-connected system, it can't. So we have another system in place where we can configure and control the Fronius by using this zero feed-in method. And it uses the local network to send the message to the Fronius to back off or not. So if you require it, that's where you configure that. Using this, you don't want to set the Fronius smart meter up. So if you've just got a Fronius AC PV inverter and no Victron system, and you wanted 0 feed in, you'd be using the Fronius smart meter. But in a Victron system, you do not use the Fronius smart meter. Use our own smart meters as part of an ESS system and use that to configure. I mentioned some accessories required. The MK3 to USB would be the main one there, and that connects the laptop to the Victron Multiplus for programming. Now, I'm just going to pop these in here just so you have them for the end of the webinar, but I'm not going to explain them. Here's just some sample wiring diagrams of how this would be connected. You'll get these as part of the pack at the end of the presentation. It's also possible to do parallel or 3-phase systems. So that's running much larger. If you want, let's say, 45 kilowatt, you can do that with 3 15 kVA multi-pluses on the Victron side. If you want an even bigger system, again, you can run up to 180 kVA on the Victron side by paralleling 3-phasing our units, which allow for much, much larger systems. Here's a few example installation photos. You can see these are larger systems. Some with DC and AC PV. There's a smaller system there, a residential system. Coming to the end here myself, so I just want to mention a few avenues of support. If you need support on the Victron side, you believe there's an issue with your system on the Victron end, we'd encourage you to contact the support portal through Victron first. So you access victronenergy.com/support. From there, there's a step through of what to do. Read your product manual, perform some basic system checks, contact your distributor through the portal option there to get you in touch with who sold you the gear on your end. If that doesn't help you or you're waiting for your distributor, one thing you can do is access Victron Community. That's available at community.victronenergy.com. And we have a special topic for Fronius. There's some 100 posts and answers in there, questions and answers. That's worth checking out as well. This can be a good pre-purchase to find out what's going on, but also if you do have an issue, maybe it's already been answered or discussed. There's also Victron Professional. So this is our professional portal for installers, and I imagine some of you have come from that to here today. Through Victron Professional, we offer Victron training. We can train you and your staff or your customers with different levels of support. We offer webinars live when that's available, but also Victron online training. So we have courses available there with guided videos and detailed presentations. That's available at the professional.victronenergy.com online training part. On the left-hand side there, you can see the option. We also run exam testing through there, so you can test your knowledge and make sure that you're sufficiently competent to install a system like this. And you can access our websites here. So that's all from me. Thank you very much. Are we still good, Sandro? Are you back online?
Yes, thanks a lot, Guy, for this very impressive and interesting presentation. I think we received many questions already. So maybe I want to use the next 2 or 3 minutes to do a live question and answering. So maybe David, also our off-grid expert from Fronius, is still online. David, can you hear us?
Sure.
David, did we receive any interesting question which is of common interest and you would like to address to our audience?
A lot. So you kept me really busy the last hour. Was almost impossible to follow up with all the questions, but I gave my best. So, I mean, the first question, I think it has been answered during the webinar, was regarding 60 Hertz grids. Is there a solution for 60 Hertz grid available as well? I think this has been addressed during the webinar that there is a microgrid 60 Hertz setup available, and so we don't have an issue here. Another question, which was frequency related, was there was one person asking if the frequency shifting can cause damage to sensitive electronic devices like network switches, routers, etc. My answer to that is that the power supplies that usually used in these devices, they are not very sensitive to frequency deviations nor voltage deviations. So at least I have never heard about any damage to devices caused by the frequency shifts.
Can I add to that one as well? I'll just say that the grid naturally fluctuates frequency, right? It's not a perfect 50 hertz either. In fact, normally the Victron Multiplus gives a better frequency stability than the grid does. The range of frequency shift that you'd see in an off-grid Victron Fronius system is still within the spec of the grid's requirements. So any appliance is going to be made for those tolerances in that frequency adjustment. And if it goes too far, like it would normally, then the system shuts down on Victron and in the grid and normally. So that's no different than a normal grid connected system in its tolerance.
Exactly. Then there was another question which was more related to data communication side. It was related to the data managers inside the Fronius inverters. And one guy asked if each and every inverter needs to have the data manager inside to have the monitoring in the color control. No, this is not the case. There's only at least one inverter needs to have the data manager to provide the data to the color control. As long as the other inverters are hooked up with the Fronius SolarNet ring topology, then all is good.
Okay.
And finally, maybe one short notice regarding the one-on-one rule. Of course, the Fronius part could be less than the Victron part, but not the other way around. So if you have like 15 kilowatt of Fronius inverters connected to 20 or more kilowatt of Victron inverter chargers, that of course is fine. So you don't have to match the one-on-one rule exactly. But the other way around, using an Eco 27 on a 20 kilowatt Victron system, that's not allowed.
Yeah, so I should say that it's way better for our system to have a smaller Fronius than a Multiplus or Quattro. So you don't think you have to, the rule doesn't mean they have to be equal at all times. It means that the Fronius has to be smaller than the Multiplus at all times. So it's far better for system stability if the Multiplus is much larger than the Fronius. But if they're one-to-one, that's supported and fine.
Exactly.
Okay.
All right. We're following up with all the other questions. If there came, well, at least since we talked now, there came at least another 15 questions in. So we're trying to answer them offline later, and you receive your answers, I can promise.
Okay. So thanks once again, David and Guy. Now we have come to an end. I will close the webinar now. So thanks again for your participation. I hope you learned a lot today, a lot of information, I guess. You receive, of course, the recording and all the materials from us with all the wirings and all the diagrams for further usage. Thanks a lot. Hope you're doing well. Stay fit, stay healthy, and I hope we see or hear us soon again at another maybe Fronius or Victron webinar. Goodbye. Have a good day.
Thank you all.